Good morning, everyone. My name is Gang, and as Adam said, the students who did the work cannot make it here because of visa issues. So I will be giving the talk on his behalf. This is a joint work with my colleague, Professor Danfeng, and our students. I'm going to talk about mobile deep links. So mobile devices today are changing the way we browse the internet. So users are spending more time on their mobile devices compared to traditional laptops and desktops. So obviously the big game changers are the mobile apps. So if you still remember the days you have to open a browser and use those kind of mobile websites, now mobile apps appears much faster. And also, their user interfaces are specially designed to give users sort of a better experience. A few years ago, someone even told me that apps will be the future of the web, and websites will disappear. But if you look at that statement again, it might not be entirely true from today's situation. So apps are not yet replacing the websites yet. So if you think about it, apps are those kind of software packages. They are standalone in a walled garden structure. This makes it very difficult for users to navigate across different apps like they do on the websites. More importantly, because of this kind of walled garden structure, so the mobile content is sort of hidden behind those apps, and it's really difficult to build a search engine to globally index and search every single piece of the content that is behind the walled garden. So as a result, this is what we have today. So apps and mobile websites are sort of coexist, and both are important interfaces to access online content. So in order to make this app/web ecosystem more usable, there's a constant effort to deeply integrate the two parts of the world. Mobile deep links is a key mechanism that allows websites to talk to apps easily. So essentially, the deep links are URLs that point to a deep location inside apps. So you click a link and you can open that part of the app. Now here, just give you a very quick example. Before the conference, I was search about the conference hotel, and obviously it's a sort of expensive one. As you can see in the search results, there's a lot of links, and you can easily do things like click the button, make a phone call to the hotel's front desk, and the phone number is always preloaded. Similarly, you can click another link if you get lost in the neighborhood. There's a Google map, you can navigate back to the hotel. Again, the address of the hotel is preloaded. Similarly, you can check Yelp review, or you can share this hotel information using the Facebook app directly. So as you can see, the mobile deep links make it easier, so much easier, for users to navigate between websites and apps and use them together. However, this type of convenience actually has a security cost. As you can imagine, mobile deep links are not real URLs. So they are designed for functionality, for convenience, but not for security. So the first generation of deep links is called a scheme URL or URL scheme. So it has been in Android and iOS since 2009. You might not even sort of recognize, but it's really sort of useful. So apps can register their own scheme and to the OS. And the OS will later recognize the scheme when users click the link to open the right app. So here's an example. So this is your phone, and this is a Facebook. When Facebook was installed to your phone, it will register a scheme called FB, for example. And later, when user click this FB scheme and the link, then the OS knows which app to talk to. But the problem here is that this FB scheme is not exclusively mapped to Facebook. Any other apps can register this scheme. Now, this problematic is because other apps could register FB scheme and pretending to be Facebook, and the mobile OS will get confused. Now, this could easily lead to hijacking attacks. So a malicious app will hijack the link request that's supposed to go to another app. The problem has been discussed by researchers in prior works. So this could easily lead to phishing attacks. The malicious app can present the user a wrong login page, for example. And attackers can also steal sensitive information that is carried in these URL parameters. Now, well, you will say, well, this problem has been there for, well, several years, have been known for several years. Are there solutions? Well, it turns out the major line of solution is on the user side. So when two apps, for example, register the same scheme, and the OS will show you this dialog and let user decide which app they wanted to open. But unfortunately, even for this user prompting, it can be skipped at certain conditions. So for example, if the malicious app was installed before the actual real app does, no prompting. If the malicious apps, tricks user to click this always button, then just prompting for the first time, then no more prompting after that. But the bottom line here is, if a user is the only line of defense, that's a bit concerning, because historically, we know users are not really good at this. So maybe Android and iOS also realized this issue, and recently in 2015, so they have this deep link, 2.0. So Android called them app links, and iOS, have to make a slightly different name, so universal links. So let's stick to app link for this talk. So the idea of the app link is that apps should not make their own schemes. So let's all go back to the standard HTTP, HTTPS. More importantly, there's a new security feature that allows apps to verify their links. All right, so I'll talk about the security feature a little bit later, give you sort of more details. So I wanted to mention another type of secure version of the deep links is called an intended URL. This is only working for Android and certain Android browsers. Now the idea is sort of if FB scheme can be hijacked by any other app, so let's not use FB, but instead use the intended URL and specify the package name of the target app. Now the package name is uniquely guaranteed by the app marketplace. So as long as you download from the official market, that should be okay. Now that we have different types of deep links out there and all have different kind of security guarantees, the question is really about how they are used in practice. Given a particular type of deep link, are apps actually hijacking other apps using this type of deep link? For the newer version and a supposed to be more secure version of deep links, are they truly secure? How effective they are in terms of protecting users from hijacking attacks? So these are the questions we're interested in, and to answer these questions, we perform a large-scale empirical measurements. So we try to analyze the deep link usage across a large number of apps and websites. For this project, we primarily focus on Android because of the dominating market share and also the availability of the source code. But at the same time, we perform parts of the analysis for iOS as well. So that's why we have Android keywords in our title. So I will mention a little bit about the iOS result in the later part of the talk. So this is the outline of the talk. First, I wanted to talk about our measurements on the adoption of different type of deep links. And particularly for the new app links, we try to perform a security analysis to understand, are they truly secure, or are there any vulnerabilities? Then we focus on the hijacking attack and try to characterize how apps are hijacking other apps' deep links. And finally, we combine the app-level analysis with the website analysis to look at how likely a user will encounter such links on the web. So our analysis is based on a large collection of Android datasets and also the website datasets. So in total, we crawled sort of 2 snapshots of Android apps in 2014 and in 2016. Each snapshot has about 164,000 most popular apps in different categories. So for the websites, also we focused on the popular ones, so those that are more likely to be visited by users. So we use a dynamic crawler built by other researchers to mimic a mobile browser to visit the top Alexa top 1 million domains index pages. So we didn't go that far to crawl the whole sites. So that's just only give us a sort of a large but a lower bound of the deep links on the web. Now with this data set, let's look at how deep links are used by apps. So in 2014, out of the 164,000 apps, we found that it's about 10,000 registered the scheme URL. So that's the older version. And about 4,500 have app links. So in 2016, the numbers, and both numbers actually, have almost doubled. So about a 90% growth rate of the adoption of deep links. So this shows that mobile developers definitely get interested in deep links to integrate their apps with the sort of the web front. But more importantly, we observed that the vulnerable, the older version of the scheme URLs are still used and actually getting popular. Now the question is, well, for the new app links, are they actually properly verified? And that's the sort of the key selling point of the security feature. Now, here's a little bit of background. App links has a sort of verification mechanism that allow you to verify the links on the app. Now, this is how it works. So again, using Facebook example, so if you are a Facebook developer and you wanted to make your app register this facebook.com, that's your own domain. Now, you register that when the app was installed, and the mobile OS will contact the actual Facebook server on the web to verify this claim. Now, Facebook developers say, hey, I want to make this happen, so I have to put an association file under the root path of a HTTPS server. So this is all required to make this happen. Now, once the link is verified and the user can click the link and it automatically opens Facebook app without the prompting. Right? So because this is trusted and no other app can do that other than Facebook. So iOS and Android handle differently in terms of how they handle the unverified links. So for Android, if a link verification is not successful, Android says, well, it still works, but it will trigger the user prompting just like the scheme URLs. iOS says, no, we cannot open links if it is not verified. So that's the difference. Now, with that in mind, let's look at how app links are actually verified in practice. So out of the almost 9,000 apps that have adopted app links in 2016, so 4.7% have actually enabled the link verification process in the app. Even smaller number of apps have made everything correctly. So even though it sounds like a straightforward process, we found lots of mistakes. Forgetting to put the association files under the right path, using an HTTP server instead of the HTTPS server, which will make the verification fail, using invalid formats for the association file or the manifest file. So even popular apps like Airbnb or Amazon Music has this type of errors when we crawl them. Well, this is the statistic in January 2017. So for our camera ready, we revisited the problem again. 2 apps make the correction. So obviously they didn't even realize that it doesn't work. So we sort of in the process of notifying them and try to help to solve the issue. But really, out of all the possible reasons or potential reasons why this is happening, we think that this is our personal, sort of our own speculation. It's possible because the lack of incentives. So because if the app links is not verified, it kind of still work. So developers might not be motivated enough to sort of take the actual step to make the verification correct. So in addition to that, there are more bad news. We found a new vulnerability in the app links. It's kind of an over-permission, right? So the idea is that this vulnerability allows a malicious app to open arbitrary app links and escape the user prompting. So user won't know it can happen. So the reason is when user click this, always using this app to open this link. So this sort of set a preference. And this preference not only goes to the link that a user actually sees on their screen, but also any other links that this app registered. So just to give you an example. So suppose the attacker builds an app called a recipe app, and user was sort of visiting recipe.com and tried to open a cupcake recipe. So this app can show up, say, hey, I can open this for you, give you a better user interface, choose me. Now, as you can see, user can very possibly to click the rightmost button always. But what happens behind the scene is that this preference not only goes to recipe.com, but it could be any links that have registered on the manifest file and a user can see them. So let's use bank.com as example. So later when user visited the actual bank.com using their browser and click the login button, what happened is that this will not trigger the HTTPS request that you expected, but actually this request will go to the recipe app first, because OS think user like the app, so let's let the app to handle this request. Now the username, password could be in the URL parameter, and it will be intercepted by this app. To make this more stealthy, you can quickly bounce user back without them even noticing. So we implement this prototype, and we show that you can do this within 0.75% a second, which is barely noticeable by human eye. Now, the root causes of this problem is essentially the over-permission, right? You give too much trust to that app by user clicking always. We reported this problem to Google Android team in February, so the established case in May, so we believe that they'll try to address this issue in the next sort of OS update. Well, so far we shows that the old and vulnerable schema URLs are still widely used, so they are sort of vulnerable to hijacking. So the app links, which are supposed to be more secure, are not really commonly verified, so a lot of unverified links. So this suggests that it's still possible, in theory, apps can hijack other apps using the deep link mechanism. So the next I wanted to sort of dig into the app data to look at how apps are actually doing this in practice. So in order to identify the hijacking attack, the first thing we do is to group apps that register the same link. As you can see, out of the 18,000 unique schemes that are in our data set, about 4% are registered by more than one app. And for app links, out of the 18,000 unique app link hosts, we found about 18% have been registered by more than one app. Now, this is just within our data set. In the sort of broader collection of data, sort of app in the wild, that could be more. So this is a sort of a lower bound. But after carefully examining all the sort of collision groups, it turns out that not everybody is malicious. So there are definitely cases where multiple schemes registered by different apps are okay. So, for example, some of the schemes represent general functionalities. So schemes like Geo and Tel. So Geo, for example, is for apps that can handle GPS coordinate. You click a link, they open the GPS location on your map. So this could be Apple Map, Google Maps, even Uber, right? Now, another exception is the third-party schemes. So those are used by third-party libraries and APIs. Again, it's expected for multiple apps to use them. So they really sort of our focus should be on this per-app schemes where they represent individual apps. So at the same time, for app links, they have a sort of similar clarification, but they don't have this kind of a traditional functional category. So the real question is we need to identify those kind of per app links to look for malicious hijacking. Well, we don't have ground truth, so we have to do this manually by labeling the per app hijacking. So we have 3 judges who are all paper authors and also experienced Android developers. So this is what we found. Well, during the labeling process, we actually follow some useful guidelines. For example, for the functional schemes, So the Internet Assigned Number Authority actually has a list of common functional schemes that has been used in the web for many years, and those are very useful references for labeling the functional schemes here. For third-party ones, they also have very clear indicators. So often cases, the third-party libraries and APIs will show these kind of tutorials and documentations online to teach you how to use their API. So we can find a sort of evidence there. So the leftovers are the per-app hijacking cases, and we also make sure that they are not from the same developers. So in our paper, we actually talk about the possibility to automate this process using machine learning. It turns out to be really difficult, but if you're interested, you can see more results in the paper. So now let's look at the per-app cases and look at how sort of some of the case studies to show you some actual attacks. So the most common cases are the traffic hijacking. So basically, a smaller, less popular app, you often register the link of the popular apps to hijack some of the user clicks and user traffic. As not very surprisingly, so Google.com is the most popular target, Google Maps as well, and also Facebook, Airbnb, and those kind of popular names you can recognize. And also, this type of hijacking often happens between close competitors. So these two apps, for example, are both sort of taxi booking apps, but locally in Qatar. Now, the first one is more popular and has been integrated with hotels and a restaurant. So the smaller player just say, all right, I will hijack every single link you have. So users might have a chance to open me. The more dangerous cases are really those that can act as man in the middle. So we found a couple of redirection apps. So their job is pretty simple. So when users click those links, they open the corresponding apps for users. That sounds a lot like what Deep Link already does, but those apps are sort of kind of useful because they can open apps that have not registered or used the Deep Links just yet. But that creates a lot of problem because they actually register a lot of sensitive links. So for example, the URL lender apps registers payment.ebay.com, but the official eBay app says, no, we don't want to use that link for open the app. That's kind of dangerous. So that's one case. Another case is the register paypal.com, which if you log in, you will have a sort of session ID in the URL, and the redirection app will seize everything in the process. And they also happen to write down to their logs. Well, so far we show some, the hijacking links on the app side, but really let's now look at the websites to look at how likely that user will encounter some of the hijacked links on the web. So by analyzing those 1 million web pages, we extract all the possible deep links there, including the intended URL. So they have this kind of clear indicator. Now, as you can see, the y-axis is in log scale, and for schema URL, we found about 400,000 of them. For the app links, about 3 million. And for the intended URL, only 1,000. So covers about 0.05% of the web pages. So they're really underused and has sort of a minimal impact to mitigate the threat. So among those extracted deep links, then we matched against our app level analysis to look at how many are actually hijacked. So as you can see, we focus on the per app ones. Those are the suspicious or malicious ones. So for schema URLs, there are about 7,000 are hijacked by some of our apps that in our data set. And for app links, more than 2 million. So this is 300 times more. So it turns out this new app links actually introduce more hijacked links on the web. Well, if you think about it, before app links are introduced, well, lots of HTTP and HTTPS links carry sensitive parameters already out there on the web. Introducing app links without verifying them basically says, all right, let's just all hijack all of those links. So I wanted to sort of quickly summarize. So we showed that the old and vulnerable schema URLs are still widely used by both apps and websites. At the same time, the new app links, which are supposed to be more secure, actually make things a little bit worse. So app links are rarely verified in practice, and or rarely do it correctly. So I want to say this is not just the problem for Android. So we did some analysis for iOS apps as well. About 15 out of the 12,000 apps also misconfigured the link verification process. It looks like straightforward, but all kinds of mistakes happen. In addition, there's a new vulnerability for app links, and also they introduced more hijacked links to the web. And a final note is that for the intended URL, which is Android exclusive, does not really get much usage on the web. So they also have sort of a minimal impact to mitigate the threat. So as a sort of a final slide, I wanted to briefly mention a countermeasure sort of suggestions. But again, nothing's perfect, because any sort of decisions you do, you will break something. That's the problem when you design something not secure in the first place. Any add-ons have problems. So for example, what we can do is to disable the per app schemes. Right? That's the source of the hijacking. But the problem is this. This is exactly what iOS does. So you see this kind of error message all over the place. Broken links. There's already lots of scheme URLs out there on the web. Also, for Android in particular, lots of apps or phones are still in the older version of the SDK. And again, so the new app links are not available for them just yet. But for apps that do have app links on the phone, well, I think the better idea is to enforce the link verification. And again, the apps that don't have a web front will need some additional help. For example, I think Google's Firebase is sort of offered this kind of web hosting to verify the link, the app links. And finally, for the over-permission problem of the app links, yes, I think we should fix it. There's no bad consequences for doing so. With that, I will conclude. Thank you for your attention, and I'm glad to take questions.
If you have questions for our speaker, please come up to one of the microphones, state your name and affiliation. It's just like class, I can keep looking.
Hi, this is Lena from UBC. So in your talk, you mentioned you analyze native apps, but recently Google actually propped the instant app. Do you think you will also do this analysis on instant apps, or what do you think for instant app about your work?
Sorry, I didn't catch the keyword. What app?
Instant app. So Google 2 months ago, very recent, it's kind of a more fast way to use a native app. You don't need to download your native app.
Yeah.
If you want to fast one-time access, you can use the instant app.
Yes, I do aware that they have this kind of hybrid version where you can temporarily use sort of a kind of a web version of the app, but don't have to really download the whole thing. Unfortunately, we haven't actually analyzed what's happening on that side, but I think that would be interesting to look at it for the next step.
August Ortiz, Google. So I'm curious, with the app links vulnerability, how does it react if say the Bank of America app was installed first, so it gets verified for bank.com, and then the malicious app gets also verified and includes bank.com?
That's a good question. So if the bankAmerica.com actually installed on our phone, let's start over. So if the Bank America app was installed on our phone and the app verified that particular link with the website, then the hijacking won't happen. But there are two problems in this. One, the Bank American app may not be installed on our phone, so the malicious app can do that. But more importantly, Bank America app does not register any app links just to avoid this kind of scrutiny. So a lot of apps try to avoid using app links to avoid this potential problems, and that means that any other apps can just use that to actually hijack, so make things more vulnerable.
So does this suggest perhaps a countermeasure where apps that want to prevent, or services that want to prevent their URLs from getting hijacked would register the URLs to do nothing, say, so that a malicious app can't over-register it?
Yes, that's sort of the potential countermeasures from the service side, and that would be something to do. But really, the better choices is Android covers the problem.
Thank you.
Yeah, so I'm curious whether this is a good thing, these deep mobile links, because part of me feels that now you're kind of pointing to content that does not exist on the web. So for instance, to segue slightly into the next talk, spoiler alert, they're going to be using the Internet Archive to look at old websites. With something like this, how can we kind of archive and preserve these deep links that point into some app code that could change at any time, the company could go away, all of that?
I think that's an excellent question. All right, so one big push for the app links and many others is to make the mobile content searchable. Right? So I think one of the problem is that because the word garden structure, everything is hidden, so they want to have more visibility. Now, for app developers, they have absolute incentive to do this. It's more like attracting more users from the web. Do you think this is a good thing? It's really hard to say. From a security perspective, I don't think this is a good thing to fix the old problem by adding new problems. But at the same time, do you want to make the Google mobile content searchable? Yes, absolutely. So it's just a matter of finding a sort of better solution and probably a little bit more, strong to enforce everybody to do everything, because Google and iOS can do that if they want to.
Nice.
I don't speak for Google, by the way.
Phoebe Rouge again for the FTC. So I wonder, would you advise people who use Android right now to not click on the thing that says always use this app, at least for the moment? Is that as a security countermeasure?
In terms of dealing with users, one thing I learned from lots of other user studies I performed is that users don't understand what's going on. So one thing is that do you want to communicate every details to user and try to convince them to understand the risk, or you do the decision for them? I think this is probably one of the things that we have to do decisions for users.
Do you click always?
I still click.
Great. Let's thank our speaker.